Okay, good. Someone is recording this. Technology will disappoint you, but don't worry, we got this. Why technology feels so. Give me a minute, guys. Can you guys hear me?
Yes, we can hear you.
Yeah, sorry, I don't know what happened. So I prepared for this. My laptop decides to crash because
You can continue.
Are you needing me to share from here? If you need me to share from here, I can do that.
I hope it's not hanging.
you guys can see my face.
No, we
I don't
can.
know
Well,
what's
maybe you can go ahead. Yeah, we can see
okay.
it now. Yeah, we can see it now. We can.
Well, that's the disadvantage of technology. It messes you up. Um, let me try to share my own screen. I hope he's back. Sorry, guys. It makes you look like you don't know what you're doing. Even my drive wouldn't work. So please, if you can share the screen, just go ahead and share it.
All right, it's okay. I'll go ahead and
Yeah, if you can, just go ahead while this
go ahead
comes
and,
up.
okay, I'll download the last one you sent to me. So I'm needing like just some sort of 1 minute or
See,
download the latest one. There we go. When last did you update your laptop?
I think I did yesterday, but I think I'm back. Sorry about that.
Yeah, it happens. Even me, I updated yesterday and today they were telling me it's very slow.
So can you guys see that screen now?
Let's see, but
Yes, we can. We can.
Okay, good. One of these guys has to. We good now?
yes, it remains to share it. It remains to present it. You are sharing.
Okay.
Yeah.
See. Okay. Good morning, everyone. Good afternoon. Good night. Thank you for joining us. My name is Roland. Um, yeah, my name is Roland, and I'm from Africa. I always tell people that, so they don't misclassify me in the area of misclassification. So yeah, I'm a grad student in DC in American University, and I'm currently working as an equality data science intern at Intuitive Surgicals. Um, Intuitive Surgicals is a famous company in robotic medical device development here in California. Sorry. Okay. I would have loved for each of the TAs to introduce themselves, but since we are constrained by time, so my friend Abraham Idu. We actually did our undergrad together. He's in Moscow, Bro Gabriel, Terkuma, and Joseph Tia will be with us together today. We'll be doing all this together. So feel free, ask your questions. Um, ask your questions, and at any point, I'm going too fast. We used to speak slow when we were in Nigeria. Now we speak extremely fast. I don't know why. So at any point, I'm too fast. Just um, ask me to calm down. I will. And yeah, and let's have fun together. It's an introductory class to ML, so don't expect so much. But look, what we are trying to do today is to show you where to dive into. All right. So to show you what's possible, like we usually see in my company, to go beyond what is possible. So that's just it. Give you the concepts and let you free flow and do whatever you want to do with it. And the good thing is this community is growing, so you're always here we always here to answer your questions and to advise where we can. Yeah. So thank you so much for joining us, and yeah, let's dive in. All right. So you've heard a lot about AI and ML. You've heard so many stories. Um, for me, the journey began. I have a statistics background anyway, so well, that was like the straightforward journey to take. But I was faced between going into theoretical statistics and doing the maths and all that, and taking the maths and doing real world good with it. So that was the choice I was faced between. And I decided I was going to take the maths and do real world good with it. And that was how my AI ML journey began. Um, so we've heard a lot. I mean, right from the start of this conference, this symposium, you've heard so much about AI that I won't be here repeating all you've heard. So I would just quickly, I heard a few things that was said yesterday about AI, about machine learning, and how to use them. So don't mix the two together, AI and machine learning. AI, just like you see in this image I love so much, is like an umbrella, and machine learning is just a subset in AI. All right. So there are other systems that you learned yesterday, speech recognition, whatsoever, generative AI, LLMs, which are like the new darlings of data scientists and the likes, LLMs, RAGs, retrieval augmented generation. I'm actually working on a project on that as well. So these are the darlings of the new AI space and the new ML space, and it's a good thing to get to know them. But mainly, you've heard so much about AI, so I was speaking a lot about machine learning. So, like, I mean, if you have just a basic understanding of statistics, right? You have a group of students in a class, boys, girls. They are boys, girls, all right. There are no third genders. You're going to get a lot of jokes from me in between. So that's the way I enjoy giving my classes. So you want to find the average of boys and girls. You count them and you take the mean and you get your averages. That's basically like your ground level statistics, right? So machine learning is about taking statistics and making it more valuable and more efficient, more robust, right? I still remember my first my first data analysis in undergrad. I did it with hands, right? Imagine having to solve about 10 pages of of data analysis. I did 10 pages of data analysis with hands. That was the last time I'm going to ever do that in my life again. So but with machine learning, as computer advances, computing power increases. So the ability, the capability of machine learning also increases. And you just heard us, if you joined us earlier, we talked about data, how expansive data is getting, and data from every source, text data, numeric data, tabular data, image data. So I'm currently studying a course as well that has to do with multimodal data. So the incorporation of both text, image, and numeric data all in one into one analysis. And so as this becomes available to us, so also the requests for new data scientists, new data skills, new analytical methods increases, and there comes in machine learning and AI. Because at the end of the day, human can think about it, but only machine can execute it. So machine learning AI is the if you like to have a Venn diagram, is the intersection between human and machine doing stuff together. Human conceives the idea, machine executes it. So learning is such a key aspect of intelligence, and that's what machine offers us. Yeah, so we've heard so much about the categories of AI. Weak AI, narrow AI, strong AI, super AI. Weak AI solves a specific problem, does not generalize. I think that's the stage we are in now, right? You feed in a particular data, and you get an expected result. You expect the result you're getting, right? So we are still in the space of narrow and weak AI, but we are getting there. We are getting really advanced and super fast. So my first advice to you is keep learning. All we do, this IB students, is to continuously learn, and don't get left behind. So you've heard a lot about AI. Hollywood. How many of you have watched the movie Transformer and Terminator? They told you a lot of things that Skynet is going to take over the world, and Transformer from outer space is going to take the world. No, that's not true. Anyway, that's a fiction. But in reality, just as we experienced this morning, my system almost crashed because I was running a model that took relatively close to an hour to fit, and I got frustrated at some point and closed my system. I didn't shut it down properly. So this morning reminded me that you did the wrong thing. So bugs, causing system to fail, intelligence is the result of careful design, development, and testing based on theory. So look, will AI take the world? I've had a lot of questions in that domain as well. People with, will AI take the world? Is my job safe? One advice I give to myself is, what's the next trend, and how do I get involved in it? Because if you're moving with the trends, you will not get left behind, and you will not have to ask those questions, because by then you will know what to do with it and how to better position yourself. So get learning and get on with the trend. So I'm just gonna move very fast. So that's my introduction. So let's go to business now. So ML concepts, right? So ML is all about data. The whole algorithms, the whole methodology, all that you know, all that you've read about is about data. Good data, bad models. You can get some sort of expected result. Bad data, good models, bad results, right? So I will not go into this as much, but I'm currently working on a project, right? There was no data available for that project. None at all. No data was available. So what do? I have to get data from PDF documents, journal publications, and I have to structure those documents into a tabular form and use the tabular form to fit a machine learning model. Now, for the past 3 to 4 weeks, I've focused on pre-processing just those PDF data, and they are in their thousands, right? So my ML model is not the problem. Getting the right data is the challenge. Is the data enough? Is it even good? Do I have to get external data? How do I go from having a good data to having a good result and having a good model in between? So the whole background about ML, first thing first, in order to get a good model, in order to get a good result, is to get a good data. Without data, there's no ML model. You would get to know a few of the algorithms available. But let me just straight out there as a start that your data determines your results. If you have a bad data set, there's nothing you can do. So much, there's little few stuff you can do, and you run into issues like hallucinations. Your model starts giving you the same results during predictions, which is incorrect, right? So having a good data set is key to having a good ML model. So first thing first, data. Get the right data set. All right. Before we jump into any other thing, I just want to let you know, get the right data sets and you can start figuring out what to do. So what are the applications of AI and ML? If you get the right data set, if you have the right ideas, you have the right data set. Okay, let's start from you have the right ideas. Do you have the right data set? Okay, you have the right data set. So how do you apply it? We've spoken about this. We heard this yesterday. Computer vision, object detection, face recognition, computer graphics, you know, natural currently my interest is in speech and natural language processing. So the topic I'm currently working on has to do with topic modeling, and by extension, building recommendation system. So recommend a decision to a particular group of people that would help them, that will reduce their workload. You they feed in a particular something into business secret like cashier. They feed something into something and something tells them to do this and they'll do that. You know. So yeah, that's it. Robotics. I mean, how many of you uses Uber? Since I don't drive in California. I use Uber a lot. You just feed your starting location and your end location and you have a route. And you have an estimated price, right? That's all ML, right? There were certain variables that were considered into giving you an estimated price. Probably a child like, okay, a mile, let's say $1 per mile, and they charge the distance that you will travel. They consider traffic into the analysis. They consider current economic forecast, and they estimate a particular amount for you. And that's why this will interest you that when you take Uber during rush hour, the price goes up, right? So those are real time analysis going on. It has already been programmed to tell you what to do, to tell the system what to do. So that's why during rush hour, your prices goes up. because those are certain factors that were considered into the design of the application. And you've also heard of self-driving cars, Tesla and the likes. And these are all programs using computer vision to be able to locate, differentiate between a vehicle, a human, a pedestrian, a road sign, and all that. These are data. So again, the whole concept about ML is first and first data. Without a good data, you can't do so much. So you heard us spoke so much about data during the start. The data drives ML development. All right. So and these are their various applications, and there are more, and there are more, and there are more. And if you have an iPhone, Siri, you speak to Siri, Siri tells you, Siri gives me suggestion to the nearest ice cream factory. I love ice cream a lot. So give me suggestion to the nearest Cold Stone factory. And Siri will give you so many advices on where the next Cold Stone is. You know. So those are all development. It's not rocket science, right? It's about conceiving the ideas and looking for the data and trying so many models, as we'll get to see today. So what are the categories of ML? All right, so I've left AI and I'm now focusing more on ML. So and we have supervised, we have unsupervised, and we have reinforcement learning. So what is supervised? So my learning is the ability to explain something from the point of understanding it as an English sentence. I try to understand something from the point of an English sentence before even bringing the maths and whatsoever into it. So supervised learning is simply you have a label data and you have features, or yeah, I think this word would be independent and dependent variable. You have dependent variable, which is your label data, and you have your independent variable, which is your features. You are trying to predict what happens in the dependent variable, which is your label or your targets, using the independent variable. I understand we are from diverse classes here, so if you don't understand anything, please put in the chats and we can quickly go over that thing. All right. So yeah. And we have unsupervised um we have unsupervised learning, right? Which deals with discovering those data sets. And we're going to go into a bit of understanding what is unsupervised, what is supervised, what are the algorithms available for the two, and what are their examples. So just like I gave the example of Uber, if you want to predict the price of a house in a particular area, all right, there are certain things that comes into house prices. Let's say the prices of houses in Lekki will be different from the price of houses in Ikorodu. So the price of houses in DC, in a particular area in DC that's close to the White House, will be different from the price of houses in somewhere in Greenbelt. The price of houses in a particular city in Tokyo will be different from the price of houses in another different city, say Kyoto also. So there are certain factors that goes into predicting these house prices. And in order to do that, we have so many methods called in supervised learning. You have your logistic regression, linear regression, random forest. And we're going to see what they are about and how to go about them, right? So later in the class. And the unsupervised, let's say from the example we're going to use, let's say you have a huge data set. You don't know what the data set is about. Say you have a huge customer data set, customer demographic information, their purchasing habits, but you know that certain customers purchase better than or shop better than other customers, and those are your high-end customers. But you actually don't know how to categorize this group of customers that you have. All you have is just customer database. So how can you sort of categorize these customers that you now have, you now do sort of a target marketing to specific customers and have a different target marketing to different customers? Have you ever come across a situation where you are browsing, let's say 2 days ago, you tried to browse for a new device or you wanted to shop for a new device, right? You were just looking with the shopping for a new computer, a new headphone, whatsoever, a new phone, and you're done with that and you just go ahead and move on to the next thing. But a few days later, when you open your Google or Safari, whatever browsing app you use, you get suggestions of different kinds of phone popping in here and there, right? Those are target marketing. So basically, you are exposed on the internet whatever you go to it. All right. So those are target marketing. Your data is being collected in real time, and they are being used to do target marketing. So between a cluster, they have developed a cluster where certain demographics, certain customers with certain demographics, with certain shopping choices would like this kind of items. So the ML model simply just gives the suggestion of those items. So this is what you're supposed to buy, and you end up shopping for it if you are not. And the third type is reinforcement learning, right? The goal is to recommend, to reinforce sense and interact with the environment and again learn to its actions. So most of us, majority of us are Africans. You know, growing up, your parents always have a way of reinforcing a particular habit on you, a particular character on you. So see it in that light, that certain things are being put in place to reinforce a particular learning ability or a particular lifestyle in you. So one thing I would advise is, as you relate with these ML models, as you relate with AI, there are ethics involved in AI. During basic ethics class, you are taught about ethics of good behavior, ethics of finding justice, ethics of ensuring that the benefits outweigh harm. You know, try to relate with AI, and in all instances, ensure that the benefits of AI, would outweigh the harm it's going to cause, because AI is capable of causing real harm. In one of my classes, we discuss how AI sort of like segregates between blacks and whites when it comes to job applications and job CV resume reviews. So these are the bad negative effects of AI. So as you develop your AI model, you want AI to be um, less biased as much as possible. You know, yeah. So what's actually, because of our time, we still have a few slides to go through. So what are the ML ecosystem? What are we seeing? It's just talking plenty story. Give us the gist. So machine learning is not one size fits all. So we've spoken a lot about machine learning, how good data applications, but there are several things you can do with machine learning. There are several models, there are several methods available. So where do you start from? Basically, the ML ecosystem is built on this guy called scikit-learn. All right, it's built on scikit-learn with and you have other platform like Keras, you have TensorFlow, and if you're into R, you have tidy models, and you have Caract, you have Fix2, you have AutoML in R. But mostly what I practice is I usually do my data pre-processing in R, and I sort of have a database I go through. I whenever I'm sure my data is clean, I push it into the database and I take that data from the database into my Python environment and I develop my models. I just have a good feel about pre-processing data in R, except they are image data anyway. So machine learning is not one size fits all. There are several methods. There are several, just as we've spoken from the start, classification, regression. We're going to differentiate those two, right? So regression has to do with, how many of us here remember our basic, what's it called? Um, um, Model, like, what's it called? Y equals to mx plus c. You still remember your basic y equals to mx plus c. That's the like foundational regression model ever. Your y is your dependent variable or your target or your label, and your mx is the x is the independent variable, right? Your c is your intercept, and your m is the slope. So all this comes together. Your c is like your constant, and your m is like what changes between the slope, what causes like a weight being attached to the independent variable. So classification, regression is simply trying to predict the existence of a numeric variable. It usually deals with numeric variables. While classification has to do with classifying two groups or three groups or four groups. You know, you want to classify, you have a business problem. You want to classify certain groups of people into one group and the other into another group. This is when you have the groups already. Now, when you don't have the groups, what do? You go into this group called clustering. And in clustering, you have several methods: k-means clustering, mini batch. We're going to look at k-means later on. Yeah, GBM, mean shift, and the like. And now, when you have so many features, you don't know what to do with it. What do? That's where you have dimensionality reduction. And chief in dimensionality reduction is randomized PCA. So this happens, dimensionality reduction occurs when you have so many features. You don't even know which one to use to build your models. So PCA gives you the opportunity to reduce the number of features. Like, it's a feature reduction approach that enables you to look at the most important features to use to develop your models. And I'm going to try to share something with us related to this quickly. So please forgive me if there's so much you have to see today. Yeah. So I wanted to share this with us a bit. How did I get it? Good. So this is what I wanted to share with us. This is the same image I shared on the slide, right? So for your learning, we will not be able to go through all the process. And I will post this on, I'll share this to have it posted on to you guys. For now, I hope someone can see this link. Now, if you want to learn, right, you don't have all the resources and you are mostly self-taught. This is something I did while learning. This gives you an approach, a place to start. You want to learn about clustering. You have a text data or you have a sample of less than 100K. You want to learn about classification or regression. Now, these are different regression models. We'll discuss more on the various regression models, right? But I want to learn about stochastic gradient descent regression. If I click on this, it's going to give me all about stochastic gradient descent models. And it's just left for me to go through it and learn about it, learn the maths, learn the different arguments available, learn the pipeline, learn how to do it to get it done. So these resources is available online, and it can greatly help your learning. Suppose you don't know anything about it and there's no one to teach you the maths or whatever about it. This is a great place to start. So this will be shared to us. Whatsoever methods that were described here, you want to learn about k-means clustering, click on k-means, and voila, you have the maths, you have the methods available. How it is done, you'll be taught. So that's to help your learning. So let's go back to our slide. Back to our slides. So these are ML models and all that. And I've spoken a lot about supervised, I've spoken a lot about unsupervised and reinforcement. The second slide I'll be sharing. This is actually horrifying, but I have something else to help you see it better. So in addition to helping you see what to do, is to show you where to get your resources from. So we spoke about supervised methods and we spoke about unsupervised methods. Now, basically, there are two. When you break down supervised method, you have the linear models, you have the tree-based model. In the linear models, you have something that has to do with sigmoid models, which are the stick regression. Linear models, as the name implies, they are like one of my professor will see. Says when you say linear, just see it as it's going linear. It's going from top to bottom or bottom to top, as the case may be. So this would also be shared with us. What are the models about? How can we use them? What are the advantages? What are their disadvantages? So this will be shared with us. I won't have to go through all of it, all right, because of our time. This will be shared to us and it will give us just a cursory look at the first understanding of what these models are about and what are their uses and what are their disadvantages, right? You don't want to use um, a linear regression model when a decision tree can do better. And you don't want to use decision tree when your linear regression model can do better. So it's not like the more robust the model is, the better the prediction. You also want to consider things like computational complexities, computational costs in developing your models. So you're going to learn about what are their disadvantages, what are their use cases. Can I even combine all three together or all two together? So those are those are things you want to consider while developing your models. And yeah, linear model, linear regression, logistic regression, ridge regression, lasso regression. So these two are what we call regularized models, ridge regression and lasso regression, basically used when linear regression fails. And also when all three fails, you have to jump into trying to do something that has to do with gradient boosting regression, XGBoost, decision tree regression, random forest regression, and the likes. So we're going to try to see how all these three fits together and try to work on them. I'm going to have to run very fast because my time, I don't want to be caught on time. So next we're going to be looking at, we've already discussed this classification, types of ML tags, classification, clustering, and regression. We've looked about it. Regression simply estimates the unknown costs from the data. You have your target data and simply defining the relationship between the targets and the features, dependent and independent again. For those in the social sciences, so we don't keep you guys so far away. Simply determining the relationship between independent and dependent variable. And we looked at classification, classifying between two different groups. Oh, he's a white, he's a black, he's Hispanic, he's black, he's Igbo, he's Yoruba, he shops at Walmart, he shops at Target. So that's what classification does to you. Now, in all of this, how do we build our model? How do we evaluate our model, right? So model training and evaluation is like is a cyclical process, right? It's not like it goes one direction to the end. So you can get stuck between training your model for almost 3 months, trying to train a model and evaluating it. Before it even gets ready for prediction, you can get stuck. It all starts with your data. Just as I can't overemphasize this. It all starts with your data, having a good data set. I'm smiling because one of my friends joined and he's showing me his face. So it all starts with having a good like I can't emphasize having a good data set. Look, you can spend thousands of dollars in a project. If you don't have a good data set, it's trash. I can't emphasize having a good data set. Good data sets makes even the least ML models produces good results. Having a good data set, ensuring good data preprocessing habits, like we'll be looking at later on, ensures that your model have so much less to do rather. It doesn't stress your model so much. All right. So it's a process having your data, splitting into training and testing. So why do we even split into training and testing? Now, I love soccer. I play soccer. If you want to go for a match, a football match, you have to train, right? Then you go and test yourself with the opposing team. All right. So training sets is like what we use to train our models to learn for our model to learn about the data set. We use the training. And when we are sure we are certain, okay, our model did a good job, we test our model with the testing set it hasn't seen before. In some cases, you have a set in between called the validation set. All right. The validation set simply is also like you have the training set that trains the model. Then the validation set in between tries to test the model with the training set. And you still have to finally test the model with the testing set. Like you are trying to make your model robust in all cases. So that's basically the reason why we have the training and testing set. And we evaluate, we make predictions. The goal of every model is to make predictions. And yeah, there's something you must learn and you must know in all ML classes. It's called overfitting and underfitting. You have to know them. If you pass through an ML class and you were not exposed, there are another concepts, bias and variance. If you pass through an ML class and you were not told about these four concepts, overfitting, underfitting, bias, and variance, go and collect your money back. All right. So underfitting is when your data, your model poorly fits your data. As the name implies, underfits. It underfits the data. It's not producing the best representation of the data set. That's underfitting. And overfitting is when your model learns so much about the data. It knew so much about the data that it started behaving so so aggressive. It thinks it knows it all. So overfitting is when it fits your model is allowed to make mistakes. All right. Your model at some point is allowed to have room for doubt. But when your model becomes too accurate, then also is a challenge. That's where you have overfitting. So where bias and variance comes in, is like you are trying to find the sweet spot that your model in biasing, your model actually does what it is supposed to do. It sticks with the model specification, the model rules, the model requirement. It sticks with it, right? It sticks with whatsoever rule that has been applied, that has been set up by the project committee or whatsoever designed your project. Your model is within those specifications. It sticks within your models. Your model sticks within its assumptions. That's bias. Now, you are also considering variance, that your model is not too far from what you expect it to be. Like it's supposed to predict, it's supposed to classify certain, somebody is black, is 6 foot tall. Let me use an example of one of my research. Someone is black, he's above this age, he's he has a familiar history of prostate cancer. By rights or given certain other clinical characteristics, you expect the person to have prostate cancer in the future, which if they don't have they don't get involved in early diagnosis or something. Now your model decides to like predict unknown. That's far from reality. So you have as much as possible to find a sweet spot between your model standing on its assumptions and not varying from the predictions that it is meant to predict. So you have to consider variance, you have to consider bias, you have to consider overfitting, you have to consider underfitting. You know, having a model with an accuracy of 96% doesn't make the model the best. You want to be sure that it's actually predicting what it is meant to predict, right? So, and another important step before I round up is data preprocessing. I had to put these slides this morning and come up with these steps because it's like without, I've spoken too much about data that I'm now boring you. Like without preprocessing your data the right way, ensuring there is no missingness, ensuring there is no strange variable, having it in the right format. I mean, we can't overemphasize this. If you have the right data, you are sure that your model is doing a good job. So these are the steps. Import the necessary libraries, sanity check. Like, do I even have the right data at all? Like, is it what I imported? Do an exploratory data of your data, an exploratory EDA of your data. See the distributions with histogram, see the outliers with box plots, see the relationship with scatter plots. Check out for missing values. Treat them. Are you going to take the mean? Check out for outliers. How do you want to treat your outliers? Yeah, I mean, you can use quartiles or percentiles in any way to treat your outliers. Check out for duplicates. You know, in building our data set, we want every row to be unique. So check out there's no duplicates and check out the distribution of your data. There should the process called normalization or standardization. You don't want one variable to have an influence, an overdue influence over other variables. So normalize your data set as much as possible. When you have categorical classes, ensure you encode them. So I don't know if we'll go into that, but yeah, that's it. And finally, the ML pipeline as a whole. It starts from data collection and exploration. Data again, data cleaning and processing, pre-processing, data again. Now, before you even get to selecting your feature engineering, transformation, see, the first 3 steps have to do with data. The first 3 steps have to do with data. Before you choose which ML model to build, either logistic regression, either linear regression, either ridge regression, either if you go for tree-based model, decision tree, random forest, I mean, random forest is already ensemble. Gradient boosting, um, neural network, whatsoever model you choose, it all starts from having a good data set. Know your data very well. Be confident in your data. Then you can now move to model training and validation. Train your model, tune your hyperparameters, right? I don't know if we have time to go into tuning hyperparameters, but there are certain parameters in your data that in your model that cannot be learned from your data. So the model will have to learn it itself. And how do you get to learn those parameters? You tune them using your data. All right. So finally, evaluate your model on your test data and select the best performing model. Like we've said, machine learning is not one model fits all. If linear regression works today on a certain particular data set, it may not work on another data set. given how data was collected or how it's being processed, decision tree may be good on one data, but it may be overfitting. While a simple model like linear regression may do a good job on that model, on that data set. So be conversant with all the types of ML model as much as you can that we have. And the two links I shared with us will also be shared with us as well. So we can use it to, oh boy, I hope I haven't gotten so much out of this, but please permit us to go straight into I expect my TAs to answer your questions. If you have any, just drop them in the chat. So please permit us to quickly go into this section, the hands-on sections, and see how quickly we can run through it. So does everyone, so far, if you have any question, please, because of our time, just put it in the chat box, and we would have time to answer it as much as possible. Yeah, so this is my collab for this camp for working with other colleagues as well. So we decided to work on collab where we can always share our ideas together and do all the stuff together in one place. So collab is hosted by Google. And if you want to do your own analysis, you have Visual Studio, you have Jupyter Notebook, and Aconda. Some of you guys have it already. This will be shared with us also. So it's just a basic, like basic, but it's to give you an understanding, sort of like a deep dive, not actually a deep dive, but just an intro into what you can do with ML. What are the drawbacks and how you can resolve what you come across, the challenges you meet while building your model. So in starting your project, I wouldn't go into setting up your environment and all that. That's for another day. I'm pretty sure you'll figure it out. You've already learned about version control yesterday. And so that's for another class. But what you want to do first is to load your libraries. Basically NumPy and pandas. I hope during the first section we heard about NumPy, pandas, and those are like the first two fundamental libraries you have to have in your Jupyter Notebook or wherever environment you choose to work with. See, I have my NumPy. Matplotlib is for plotting. You also have Seaborn for plotting as well. Then for the models I want to build, I have to split it into training and testing sets. So the sklearn library that we looked at previously helps us to do that. Then for normalization in our data processing steps. So basically these two guys, this from here to standard scalar, helps us in our data processing approaches. All right. Training and test, train test place helps us to split our data into testing and into training and testing. Standard scalar helps us to normalize our data sets, ensuring that what we're simply saying in that language is like every data is on the same scale. All right. You don't want one data to influence the other. Then still on sklearn, we are now dealing with linear model, logistic regression, when you are for classification. I know majority of us have heard about confusion matrix. So it's simply to show what our model was doing. Is he able to classify the groups that we have in our data? How well was he able to classify it? We have certain groups that are true, very true, or we call them true positives, and the false true negative. Now, you want your true positive to be very high. You want your model to be sensitive, and you want your true negatives to be as much as possible, that everything that is no should be on the negative side. And the extreme, the top right and the bottom left, you want it to be as small. Those are called false positive and false negative. You want them to be as small as possible. That's what the confusion matrix gives to us. And we'll see an example of that later on. So for our linear regression model, we have 2 or 3 data sets we used. And all the data sets we use can be found in UCI repo. So look, these are free data sets for you. All right. Just go there, get the data set you want, use it to train your model. You can search by the tasks you want to do. You want to do classification, you want to do regression, clustering. These are free data sets. You don't have to pay anything for it. So you can use it to learn your basic models to, practice. And for our case, first thing first, because this is not installed on Drifting Notebook, sorry, on Colab. This is a private repo. We have to always load that. So we load our libraries in. That's that. So we load in our data sets. This has to do with customers. Yeah, customer data set. The data set refers to the client of wholesale distributors spending on diverse products and categories. So what we are trying to do, and the target is the region. So we are trying to classify what group the customers are coming from. That's the goal of this project. We load in our data set. You can simply see your X and Y. There can be so many X's but there can only be one Y, right? So if you want to view your data set, which is a good practice to always do, all right, is to view your data. Oh boy, okay, that happens. Is to always view your data set, like get to know what your data is all about. Do you have missing data? If you have, it's going to tell you there's a null variable, but so far we are good. There's no missing data. And we have all numeric variables. That's why we see int 64. And if we want to see our categories or our target variable, we can do this value count. So we have 3 groups, 3, maybe we don't know the region it's from. It can be North America, Africa, Asia, thereabout. But because we want to build a logistic regression model is simply trying to classify, to predict what group, given a particular data set, what group that a row of observation is going to belong to. All right, let's see, going back to my prostate cancer example, will a patient that's 20 years, that's 40 years old, that's Black, that has a familial history of prostate cancer, there are so many other. Oh, my screen is not clear enough. Sorry. Can you see now? I hope this helps. Thank you. Sorry about that.
Better.
So you have these categories, and you want to decide, will this person in the future have prostate cancer or not? So the best approach to do that, you can't use linear regression because you are trying to classify between 2 groups. So our basic model to do such, to handle such problem, is the logistic regression model. All right. So for this case, we have 3 groups. This is already a multi-class prediction. Logistic regression can also do multi-class prediction, but for our case, we just want to stick with logistic regression. So in order to do that, I had to go through trying to group this into 2 class. So that's where the process of doing pre-processing comes in. You have to first of all understand the business stats, and how you go about doing that is through pre-processing. Like there's no one size fits all when it comes to pre-processing, but what you have to know is there are steps how I did it, someone can do it differently. That will be shared, don't worry. There's no one size fits all, but the steps don't change from person to person. You always have to remove null variables or treat them as you want. You encode your data, you look out for outliers, and you treat them. All right. You do an EDA of your data set. Those steps doesn't change, but how you do them may change. All right. So the second data set is California housing prices. So one of because I stay in California. You you don't want me to fetch your data housing California. Okay. Yeah, that happens to me. Anyway, this is new. Yeah. Okay. Let's get that ready again and see what happens. All right. So, okay. We're gonna get back to that. Anyway. So, where did I start from? Right. I'm working on my housing prices. For some reason, this is trying to disappoint me.
Okay, so sorry, I just have to come in. So if they have such kind of issue, how do they check the problem? How do they get their solution? Is there
Good.
a website where they can go and just sort out their problems?
Now, the first thing you wanted to do was just go to ChatGPT. Why am I having this, or why am I experiencing this? Now, one thing you have to understand is because this is hosted on a particular website, it may change from time to time. Someone may just wake up one day and decide to want to update it. But what I would do is isolate the problems before going to your website. Isolate the problem. My problem is obviously coming from housing. Here, try to isolate the problem. That's usually like a good programming habit. Isolate the problem and see where it's coming from. So it's obviously coming from housing prices. So whatever I do to not work, it's coming from housing prices. So either I'm writing the wrong code. The next step for me is to look at the error. What's causing my error? Is the HTTP error. Simply means it's coming from the website. All right. It's coming from the website. So what happens? Could it be that I didn't load a particular library? So I have to check. I have to check my libraries again. I have to check my libraries and see what happened to it. These are just steps before you go into browsing. Make sure you clearly understand what is happening. And when you are failed and you don't know what to do, the good thing is we are using Colab, right? So it can help you. It's like copying the error you found and pasting it on Google. All right. Now, Colab will tell you, okay, this is what I think is the issue. This is the same result you're going to get from Google. When you copy your data sets and when you copy your error and post it on data set, this is the same suggestion you're going to get from Google. So what are we doing wrong and what is our AI suggesting to us? We're clearly not doing so horrible. We've loaded all our data set. and it's just not working. So what am I gonna do? I'm not gonna waste your time. I'm gonna look at other datasets available. The good thing about this is that I can always get other datasets. If it's not working, we can check spreadsheet distribution. And see what happens. So basically, my dataset is not doing the best I should. So guys, what do we do? I came prepared. I want to do a regression task. Student performance. So these are the issues you run into while doing this. And it's good for you also because now I would have to teach you how to go through getting a new data set. Right? Look at this. So I simply just got a new data set from that repo I shared with us. And I'm going to try to run through the pre-processing steps, which is almost the same, like what we've done. So these are student performance. I just want to take one of them. See, from predicting one, I decided to use several data sets. So now what is interesting is I'll have to use one of them. I just want to use one of them. Okay. Mm. Um, so what's interesting is I would have to find myself a solution if it fails. That's weird. What are we doing? So, okay, I've already created targets. Is the target I want to use as my predictor, right? I want to use it for my analysis. So the process still remains the same. Everything, we just only have to change Y and change it to targets. So see, so your morning class is not in vain. All right, your morning class is not in vain because from your morning class, you're not able to do this. From your morning class, you can do this. I hope you can do this. From your morning class, I hope you can do this. So what I'm simply doing is just getting just one variable to use. I hope from your morning class, you've seen the advantages of all that you learned in the morning. the pre-processing steps, the knowing how to navigate when you run into issues. Always having a second solution. All right. So let's go into business. So first thing I have to do is I have my X variable, which is independent variable of features. I have my Y, which is the student performance. So what I can do is to first of all view my X. All right. What is my X variable? Now, does anyone know why I'm having this error? Okay, it will still work anyway. It's a data frame. Now, what is interesting is there are so many variables and I don't need all of them. If you look at this, there are so many. I don't need all of them. All right. I just want to deal with the numeric variables. So what you have to do is pre-process. In practice, you may want to do PCA to reduce the number of features you have, but in our case, I just need only the numeric variables. So what do I do? X numeric. I'll just simply select only the numeric variables. Well, good. Now, here's something cool. You guys see the code suggesting to me what to do. It's called when we learned it's called intelligence, but these days it's called code completion. So when you're working on Colab or if you have Copilot on your Visual Studio, it helps in making your coding faster and aligning with your thought process. It's not all the time that I give you the right suggestion anyway, but most of the times, if it knows what you're doing, it's going to suggest stuff to you. So what I've selected is only the numeric categories that I want to work with. I don't want to work with all the groups. Oh, that's interesting. So let's go back. Why do I have this? Why didn't it select? Now look at this, right? There's no float 64. All we have is int 64. So know what you were doing. So here you go. Right. So don't be afraid. Don't crash out. It happens. All you just need to do is have a solution ready at hand when it does. Use your Google, like research. In fact, when you see my tabs open, you see a bunch of them is YouTube research. All right. So what do I want to do first thing first is to look at my target variable, right? What do I call it? My target is Y. It's called target. And I want to just look at it before even doing anything. I want to look at what my target distribution looks like. I did the first step because I already understood what the other data was saying. My Y is called target. So this is the distribution of my Y variable. Now, what we said while preprocessing is in the steps to preprocessing our data was you have to view what your data set looks like. Look at it. Is it one of the assumptions of the linear regression is that your your dependent variable must be normally distributed, right? Must be in form of bell shape. Now, looking at our data set is a bit skewed, right? It's skewed a bit. So it's a trade-off. Do I want to work with this data set? It's not abnormally skewed, right? But in practice, you still want to consider a lot of things. You want to look at the mean, you want to look at the kurtosis, you want to look at the skewness. Does it all make sense? If it does, you want to test for normality by, there's a test, Shapiro-Wilkie test, something thereabout. You can read up on it. You want to look at it. Does it make sense? If it does, yeah, you can go ahead and look at your data set. The mean is not terribly, is not so bad from the median, right? It's not as bad as the median. You want to look at, okay, what is the distribution of the mean is this, what is the median? Is it bad? Is it something I should be worried about? You want to look at, see, so they are basically in the same range, which is good for us. So you want to just simply look at this stuff, and for that, I'm good to go. So another thing I want to do is look at my numeric distribution. How is my data distributed? That's my independent variable. I'm only doing this step for this. The next step, I would not be going through all this process. So I want to look at my numeric distribution. Voila. So what do I have? Like, there are categories, right? This doesn't make sense so much. I want to go the extra mile of looking at, if I look at their distribution, what is it telling me? What's the mean? This is where I'm looking at. I have this guy, age, will have an undue influence on the rest of the variable because it's the highest. The maximum for age is 22, while the rest are in between 0 and 5. Now, what this tells me is that this group could be a category, could be a categorical variable, but it's just appearing as numeric because the max is 4 or 5. My experience will tell me that this will probably be a categorical variable. So I may choose to want to code it as categories, or I may choose to keep it as numerical variables. And absence also have a high value, 32. Now, I don't want these two guys to influence the rest of these guys. So what do I do? That's where standardization comes in. Remember, I didn't do box plot. I didn't look at outliers. I didn't look at the relationship between the independent variable and the dependent variable. I didn't do those two. So that's something you can explore on your own. Because of our time, we are not dropping any feature because we are done with that data set. So yeah, we are moving on. So given that my data set is distributed unevenly, age and absences are higher than the rest of the variables in between, I can choose to work with age and absences just for this case, but they are still in different cases. Yeah, they are still in different measures. Regardless, it's a good practice to always standardize. If you look at the normal distribution plot, right? If you want to standardize your data, you subtract your x from your mean and divide by the standard deviation. That's basically what we are trying to do. We are trying to look at that. We are trying to center our data set. I hope anyone you've all heard that term before. We are trying to center our data set, right? And this only works with numeric variables, right? Categories, you don't need to do that. Now, when you have categorical variables that are missing, what you do is you impute with mostly the merge, the highest frequency, you impute with that. So there's an imputation method. You go through sklearn.impute and you do that. So I would start, nope, that's not what to do. Now, all this, and still in the pre-processing step. I haven't even done going to modeling. What I've done is to still pre-process my data, which is like the big part of modeling. So remember, what we are trying to build is a linear regression model, right? So I have done the pre-processing. I'm almost done. So the next step for me is to split my data into training and testing set. So yeah, let me show you this. This is what I am trying to do. Just to recall, nope, just to recall your mind back to where we are. Just to bring our mind back to where we are. That's showing is fine. So just to bring us back again, for some reason my slide is not showing. Okay. The next step is to go into training and testing, split our data into training and testing. Now, what I am doing here is this test size is I'm using 80% of my data set for training, and I'm keeping 20% for testing, right? There's no rule of, well, there's no one size fits all again, but the rule of thumb is usually 70 to 30, 80 to 30, as the case may be. 70% of the data set used for training, 30% for testing, or 80 for training, 20 for testing. So I'll split my data into training and testing set. The next step is to initialize my model. So I simply call the linear regression function. Remember where we loaded our libraries, right? We did load so many libraries. We did the sklearn, the logistic, import logistic regression we did for linear regression. So this is what we are using for our linear model. So everything that seems to be linear model inclined uses the sklearn.linear model library. So you just need to use from sklearn.linear model import the if it's ridge regression, if it's lasso, if it's logistic, if it's linear, so you import. So we initialize our models. Now, some models usually have arguments, parameters, hyperparameters. But in this case, we're not going to go into trying to look at their hyperparameters, right? We're just going to just fit the model just the way it is. But I've already done most of the stuff. I'll just walk us through it. So what I did was to fit my model after initializing my linear regression model, to fit it to the data that we splitted here, the training and testing data. This is the train set, and this is our, just to give us a clue, y x train. You can do value count because it's a numeric variable, but we can look at the first 1 to 2. Yeah, it's 12. The first one, the first is 20. We can look at what it looks like. This is what our target variable looks like, right? And this is what our x looks like, our train. And we can look at the shape of it. How many rows do we have? We have 519 observations. We have 13 columns. All right. So after that, I do tests. This is the process of testing. Predict on the tests, on the test set. The set that the model hasn't seen before. How well does it fit my model? All right. Then I move forward to doing what? The mean square, or to evaluate my model. So it's like we've gone through so many steps, right? The steps of looking at, I'm still looking for my slides. I don't know where it went. Okay, yeah, I found it. So we went through the steps of pre-processing our data. We didn't do much about, we did normalization, which was to scale our data sets. We selected the features we wanted and we trained our model. We didn't do hyperparameter tuning. But what we did was to evaluate our model with the test set. All right. So evaluate on the validation set if you have it. But we didn't have validation set. We didn't create that. So we evaluated on the test set. All right. So these are the steps we are walking through. And those are sort of like standard steps to always go through. So in evaluating different models, have different evaluation metrics. You know, linear regression, you have mean squared error, you have R squared adjusted. All right. For the mean square error, you're simply like evaluating the residuals. Oh God, I want to take you guys too far now. So you have your predictions, you have your test set. You're simply taking the average of, if you subtract your predictions from your test sets and take the average, what does it look like? You need that error to be very small. You need it to be very small. And you need your R squared to be very high. All right. But in our cases, our R square is just 11%, which is poor. It means our model did a bad job of fitting this data. Now, in some cases, we may want to tune our hyperparameters. We may want to go through pre-processing to remedy when our model fails, especially when you're dealing with linear regression. Other options to use are shrinkage methods such as lasso regression and ridge regression. Now, if I wanted to know what is actually wrong with my model, I would do something, especially linear regression, I would do something called residual diagnostics. I want to see the output of my model. The residual is basically what the output will look like. So if I do residual analysis of my model, what is it going to look like? My residual is scattered all over the place. Now, the rule of thumb for residual analysis is you want your data points to be centered around zero, to be like a cloud around zero. It should be around this line, the red line. But for our case, our residuals are scattered everywhere. That's one. Secondly, you want, following the assumptions of linear regression, you want your variance to be constant. There's an assumption of constant variance. You want that variance to be constant. Now, if you look at our own case, our variance is increasing, right? Our variance is increasing. You don't want that to happen. You want a constant flow of your variance. So another step, by seeing these two methods, I already know that something is hugely wrong with my model. So I would either go for lasso regression, which is like shrinkage method to reduce my variances, or I'll go for ridge regression. All right, both are are variable reduction methods, but lasso, which is L1 regularization, does a better job of removing those features that are influencing the increase in variance we are seeing. All right. In this case, we are not able to tell what increases the variance, but we know that the variance is increasing from our residuals. Lasso regression would shrink out, it would turn those variables that are increasing our variance to zero and keep only those variables that are a good fit for our model. So when you run into issues like this, before you go into building an advanced model, you want to look at lasso and ridge, which are alternatives to linear regression. So that is that for yep, I need to clear all my drawings. That's that for linear regression. I wouldn't want to take much of our time because our time is fast spent. Another second model we want to look at. So we have looked at a typical regression problem. We now want to look at a typical classification problem, which for that is logistic regression. So what we are trying to do from our data that has to do with wholesale customers. We are trying to group the wholesale customers. Let's assume this is the one is Africa, the two is Europe. All right. We are trying to group a client meets us and say, okay, this is my customers. These are the customers that I have. All right. These are the customers that I have. Their school, their sex. Okay. Now, this is something you should never do in your life, right? Please don't do this. Naming your variables with one name. All right. Please don't do that ever. So you don't end up mixing up stuff. So these are my customers. They usually buy channel, fresh milk, groceries, frozen food, Italian paper, whatever. So I want to group these customers into Africa and Europe, where majority of my customers comes from, and what do they look like? My customers from Europe, what are they basically purchasing? If a customer purchases 2 channel bags, let's hope it's channel bag, and he purchases 12,000 fresh meat, 900 plus 900,000, 9,000 milk, 7,000 groceries, and let's say it's the frozen yogurt, 214 frozen yogurt because I love yogurt, detergent papers, and how do we categorize that customer? Is that customer from Europe? Is that customer from Africa? So that is the basics of logistic regression. Is there a maths behind it? Yes. It deals on probabilities. We just want to know the probabilities of a particular customer belonging to one group as compared to the other group. All right? So same approach. What you will see is all ML models basically follow the same approach. If you know one very well, you are going to have a solid grasp of the rest of the model. The approach to building them are the same. Pre-processing, initializing our model, fitting our model, predicting our model, evaluating our model. The processes are the same. The steps are the same. Only what changes is how you do your coding. Really, that's what changes. But at the end of the day, two people can work on the same data set, different coding styles, and arrive at the same conclusions. All right. So I did initialize my customer. All right. So I think I changed the name, but that doesn't matter. I changed the name, right? If I don't, that's fine. Okay, why customer? These are pre-processing steps. Don't beat yourself too much if you don't yet understand what's going on. I shouldn't have changed it, right? If you don't understand what's going on, don't beat yourself too much. It takes a bit of a process, but with time, I'm pretty sure you will understand what you're doing. So yeah. So you split again into training and testing sets. You initialize, you fit. All right, you make your predictions. I earlier told us about confusion matrix. true positive, false positive, false negative, true negative. Now, how do I evaluate my models, right? Let me show you something. The value. How many zeros do we have? 316, and we have 124 1. All right. Now, this is my 0. This is my 1. My model was able to classify 106 zeros as 0, but it couldn't classify any one as 1. All right. That is not good. That is not good. It did a good job in classifying my 0, but it did a poor job in classifying my 1. I want it to be as much as possible evenly distributed. So that's one example of a bad model. And in this case, what our model is doing is what? Underfitting. It's underfitting our data set. So how do I resolve underfitting? Is I train with more variables. I tuned my hyperparameters, my model hyperparameters. I either work on increasing my tests or my training set. If I get more observations, I can increase my test set. I can increase my training or test set. I tune my hyperparameters. And if it fails, I use a different model, as we will see in this case. So I didn't go through training my hyperparameters. I didn't go through tuning my hyperparameters. So what I did was using a different model. Now, when we had a final evaluation on our model, the accuracy was 80%. This still underfits because now accuracy can be deceptive. You can have a high, just like I stated when we started that, you can have a high accuracy of 90%. It doesn't mean your model is doing a good job. You want as much as possible to evaluate everything your model is doing. That's why we use residual diagnostics. That's why we use confusion matrix to actually see what our model is doing. And in this case, we can see that despite having an accuracy of 80%, it's doing a bad job, right? So you want to know some of this stuff. So I'll not go down there. So what do I do when my model is failing? I've given us the example of either getting more training, more observations, tuning our hyperparameters. The third choice is to test our data set with a different model, and decision trees and random forests and the rest of those families are good, they're advanced, they're sort of robust models we can use to train, to build on our baseline models when they are not. In fact, I think the logistic regression is a good baseline model to start with. So from there, we can build on the next set of models. Decision trees are like, you have a tree. Let's say you have a root node, right? Okay, I'm going to play soccer today. Let me see, my initial decision is I'm going to play soccer today. I have yes, I have no. The next condition is it sunny or is it raining? All right. If it's sunny, yes, I'm going to go and play. If it's sunny, yes or no. All right. I can just leave as let's leave the no part and focus on the yes for now. So the next condition is it sunny? Yes, no. If it's sunny, yes, then I'll go and play. So I move on. If it's no, I'm not going anywhere. I'm staying in my house. So that condition is yes. If it's sunny, so move to the next step. The next condition will be, do I have my football, soccer boots, and shin guards accessories available. This is yes. This is no. If I don't have it available, condition ends. If I have it available, then I play soccer. So that's basically what decision tree is about. You're making a decision to either do something or not do something. But in this case, it's a tree. So you are going from roots to leaf nodes, right? You're having the pure decision tree will simply say, okay, I have a pure leaf node when there are no conditions. Again, when a particular node is standing alone, that's a pure node. All right. The links I earlier showed us to the website are good resources for us to learn about decision trees. Just like I said, we are not really teaching the theories behind it. What we are showing you is the implementation. So when you come across the theories, you are able to relate the two together. All right. So yeah, that is just a brief about decision trees. So again, the approach is the same. I have basically done the same thing with my model. So I'm going to use what I did with logistic regression. I'm going to use the same train and test split to build my decision tree and random forest. So bear with me, we're almost done. So yeah, why did that error happen? I didn't initialize.
Sorry. How long will you be done?
Yeah, just 10 minutes. I'm done. 10 more minutes, guys. Sorry, 10 more minutes. I initialize my model and I evaluate. It didn't change. Confusion matrix to see what's happening. See, it did do something, but well, that's not still what we want. I didn't bother to go deep dive. Same thing with random forest. Now, random forest is the same thing as decision tree. In fact, they are basically the same. But in random forest, or as we call it, bagging. So it simply builds different samples. It creates a bootstrap of our samples and fits those samples on different decision trees and take the average. So random forest is like a collection of decision trees. So you have so many decision trees in one model. That's a collection of random forest, and that's why you see the accuracy quickly jumps, because it's decision tree is random forest. It takes so many decision trees. So again, I won't spend so much time on that. I wanted to spend time on XGBoost, but our time is fast spent. So I'll go to gradient boosted regression, right? What was the question? Please, if you have any question, you can start dropping. Thank you. If it is the Colab platform that is using to run the analysis we are presently, yes, I'm using Colab. After processing data with this app, how do you export or print the final results for usage? That's a good question. So if you have a presentation to give, you just export the images to your slide. If you are building an app, you download your Jupyter notebook. You can always download it. You download it and you maybe use Docker or Heroku to deploy your app with your app interface, and maybe you have an HTML front end you want to use with it. Yeah. So gradient boosted regression. Right. I'm going back to my regression where I specify my regression. Yeah, I want to use this now. So please don't do that. Always have solid naming conventions for what you're doing, so you don't have to mix things up. So gradient boosted regression is like the whole idea about boosting models is like you have so many base learners or base models, and each model is building on the prediction of the previous model. So let's say I have model 1 and I have model 2, I have model 3. Now, what boosting, I'm using the word boosting, gradient boosted regression is one of the models in boosting methods. So what boosting does is, whatsoever this guy predicts, the next model will look at the prediction of this guy and it will assign weights to those predictions that were wrong. It will boost those predictions that were wrong and try to improve their predictions. And if it fails, the next model takes from where it stopped and boosts it until there's a more accurate predictions of the observations. Now, one has to be careful that it doesn't run into overfitting. In trying to get the best model, you don't overfit your data. Boosting can actually overfit most of the time. All right. So that's just a brief about boosting. And you can also do both classification and regression in boosting as well, boosted models. So in this case, we are doing regression. So you have gradient boosted classification, you have random forest classification, you have random forest regression, you have decision tree classification, you have decision tree regression. So whatever you want to do. So they have their other side. So quickly we run through it. How terrible are we? Very terrible. Our mean square error is still high. Our R square is still poor. All right. Now, I didn't tune my hyperparameters in all cases. I didn't. Now, these are things I didn't do. Just to give you an idea of why we're having poor results. I didn't tune my hyperparameters. I didn't look at scaling or normalizing or transforming my data set. I didn't do all of that. I didn't do as much feature engineering. Remember, I pointed out that the variables we see or the features we see in between can be categorical variables, but we are using them as numeric variables. That may influence our analysis or our results. All right. So these are things you want to consider because of our time. That's why I'm speaking about it and not doing them. So these are things you want to consider. Feature engineering, pre-processing is a big part of ML. In fact, you can't leave the two out, or otherwise you get the kind of result we are getting. All right. So the last model I'm going to quickly run through is clustering. Suppose you have an observation. You don't know what group you want to classify people into, right? Let's take an example of the customer data set. You don't know if one customer should be in Europe, should be classified as a European, or you don't know if you should classify the other customer as an African. But you want to be able to classify them. Clustering is it's a part of unsupervised learning where there are no labels available. So you create labels by clustering. All right, clustering setting groups together. And how clustering basically works is it uses an engine called Euclidean distance. That's like finding the average and clustering groups that are closest to each other in the same group. If they have the same distance from the minimum distance between two groups, they are in the same clusters. All right. The clusters are called centroids. All right. You have maybe in a case you may have like 2, 3, 4 centroids. And those centroids, what you are trying to do is that there's a form of homogeneity between a particular cluster. And you are trying to reduce the variance between a group of cluster. You are trying to reduce within cluster variance. I'm trying to increase between cluster variance. That's, I've spoken a lot of whatever, but see it this way, right? I have cluster A, I have cluster B. Now, I want every group in cluster A to have similar characteristics. That's within cluster variability or homogeneity of clusters. I want them to be alike, to have the same characteristics. There should not be, like, if everybody in this group should be like, if their heights should be like 5 foot or 6 foot. If I have somebody in this group in cluster A and in central A that's 7 foot, that's the problem. My cluster is not homogeneous. All right. So I want as much as possible in clustering to increase the homogeneity of my clusters. But between the two clusters, cluster A, I'm allowed to have it very, in fact, the more heterogeneous they are, the better. All right. The more there's an increase in the variance between the two clusters, the better. But within itself, the approach is like, and we're going to see a diagram that shows how unique clusters should be. All right. So in this case, I'm using obesity data set. I'm trying to classify groups of patients into either they are obese or not obese based on the characteristic. Now, clustering usually deals with just numeric variables. Of course, there are other clustering methods that can deal with categorical variable, but the k-means clustering that we're working with deals with just numeric variables. There's a way around dealing with categorical variables if you still want it in your cluster, is to do label encoding, is to encode it as numeric variables. All right. So quickly, all glory to God, I have done the coding, so it's just to run it. And we are done here. And this is my data set I got from the UCI repo, and this is what the data set looks like. Gender, age, height, weight, family history of with overweight, FA, I don't even know what that means, smoke, calcium, public transportation, and all that. That's what my data set looks like. There are categorical variables, family history, gender, some smoking or something. Yeah, public transportation and all that. So the way to deal with them is to, first of all, just sort of plot what you have. Right? Data visualization, exploratory data analysis is a big part of pre-processing. All right, see the distribution of what you have. What does it tell you? Sometimes it's quite high. Yeah, we have an uneven distribution. Most of the respondents, they're equally distributed between male and female, almost equally distributed between male and female. Family history of overweight, most of the respondents is they have a family history. Someone in their family has experienced overweightness and that. And yep, that's that. Most of the respondents is they don't smoke. So that's what you could draw. It gives you an idea of where you're going to. So again, if you want to deal with categorical variables, right, and you want it to be your clustering, you can either transform it to numeric variable using label encoder. So what it does is, like, it looks at the arrangement of alphabets. You know, alphabet A is 1, B is 2, C is 3, and the likes. So what it encodes it is, it looks at yes and no. No will be 1, yes will be 0. It looks at their well, in binary form. If we have yes or no, no is 0, yes is 1. So it looks at that. That's the exception. But in different cases, it codes it according to how they appear in the alphabet. So I did a label encoder of that. These are their, so you now have a numeric representation of your data set. Yep. And well, this is it. I haven't run. Okay. What? Okay. Oh, it's not a data frame. Let's help you. So, well, I'm still working with it anyway. Yes, done what I wanted to do. So I can either use numeric or I can include my categorical variable, but I choose to use numeric in this case, all numeric. So I run that. In clustering, you don't really need the testing and so much as the training and testing set because it's cluster, it's not supervised, right? You are not really testing how best your model fitted, but you are simply saying how best you have, how best the groups you have are. All right, so you're simply just going to test with the data set you have. You just split it into training and testing. So I selected the numeric. I called my clustering libraries. Now, what is interesting to know is it's not just one cluster libraries we have. There are so many of them. When you hit cluster, thank God for, so you have already so many of examples of them. So I would encourage you, no, for a start, I would say don't use Copilot. But after a few months, try and install Copilot in your system. You can use Copilot on both R and Visual Studio. I use it in both R and Visual Studio. So what am I trying to do? I'm trying to build a clustering algorithm that groups patients into either being overweight or underweight. All right. So I will not bore you with going through as much of the algorithm as or the tricks behind it as much as possible. But what I'm trying to find is trying to find the best distance between clusters or find the number of clusters that I should have in this data set. So just like we said, this is an unsupervised learning. I don't know the number of clusters. So I'm trying to determine the number of clusters. And in doing that, I want to find the best cluster that groups my data set. It could end up with 3 clusters, it could end up with 4 clusters, it could end up with 2 clusters. All right. As we go along, I will show us how to evaluate what's best. What's the best cluster or what's the best number of cluster to use or find. Yeah. So this is like tuning our clustering model. So I developed that and I looked at the script plots. Now, in my first class in clustering, what they told us to do was to look at your elbow. Yeah, this is your elbow, right? So to look at the elbow, where the elbow turns, that's your best cluster. That's what I was taught in my first clustering class. By just looking at the plot. That look at where your elbow is, and if it turns, that's where your cluster, that's your best, that's your optimal number of clusters. So that one has stick in my head from uni agric. You people have called it a different name now. Yeah, that's the best number of cluster to use. So in our case, it's 2 seems to be the best cluster to use. So for the person asking, how can I use this for presentation? If you produce a plot, you can easily copy the plots and post in your slide or save it somewhere and use in your slide. All right, so for me, I have selected 2 as being the optimal number of clusters that I should have. And I now use 2 to fit my clusters, all right, to build my clustering model. And yeah, just take the cluster centers, the mean of all the observations, centroids. These are my predictions, right? Which cluster each observation should be. And yeah, I'm just running through this. So at the end of the day, I have my cluster. So I'm saying someone who is the I don't know what So someone who is a female, age 21, has a height of 1.62, is weighing 64. Yes, overweight, zero, whatsoever. Sometimes take public transportation, should be grouped into cluster zero. Now, cluster zero could be a negative effect, could be a negative of outcome you want to look at, and cluster one should be a positive outcome. Let's say cluster zero could be overweight, cluster one could be underweight, or as the case may be in your own case. So in order to have a good grasp, I try to visualize my outcome, and this is what my cluster look like. So I'm clearly saying that from, let's say, from 15 years and above, right? If I use 0 as underweight and 1 as overweight, from 15 years and above, and the person weighs tops 80, the person is likely to be underweighted. Maintaining a weight of 80 could mean the person, remember I just visualized just age and weight. So the person is about 80 and weighs from 18 years and above, is underweight. And let's say the person weighs above 80 to 180, that's overweight. All right, so it makes sense a bit, all right? So now, if I have my cluster, how do I evaluate my model, my clustering model, if it at all makes sense? I use something called the silhouette score. The silhouette score tells us, is like your accuracy for clustering, right? It gives you an idea of what number of clusters is optimal and how best in percentage is that cluster when you utilize it to clustering your data set. And in our case, I did visualize it. And cluster 2 has the highest silhouette score, which means we did a good job, though we would have loved it to increase. But yeah, that's it, 57% thereabout. I wanted to do a 3D plot, but I was out of time then. But yeah, ladies and gentlemen, I've taken 1 hour, 12 minutes of your time, or 30 minutes. And it's been fun babbling and talking to myself, but I think I'm going to take a break here. And thank you so much for coming and for listening. And yeah, please, we are open to your questions and whatsoever you want us to discuss about. But that's it from me. Now take it away, Esther.
Okay, thank you so much, Roland. This was fun. It wasn't blabbing. You could see things and some things making sense. Implementation of those things you used to hear. So I think it makes a lot of sense seeing it live and getting to hear it in a better context. So thank you so much. I don't know if we have questions because we are 15 minutes behind time. I think that's because we had some technical issues. So if you have a question, please can you drop it in the comment section you want to say? We will just use a few minutes for questions and general. You can ask any question from any of the sections and even this one. And if you have a comment, you can also, this is also the time. This is the last section. So please, yeah, free. If you want to speak, you can raise your hand. And if you want to type, you can put it in the comment section. Also, while we are waiting for that, please, for the presenters, I don't know if you are comfortable with, we're going to be sharing our official means of communication. But there are some persons that would want to reach out to you personally. If you are okay with it, you can share your official means of communication that they can reach out to you if you are comfortable with it.
Sorry, I have a question, please.
The main. Okay, before if you have. Okay, Joshua, please.
Okay,
That person, sorry, if any other person have a question, please raise your hand or just type. Yeah, please go ahead, Joshua.
also I wanted to ask that, um, so to learn, yeah, Roland spoke about a whole lot of things. So, and we know in the morning we started with using the basics of Python, the strings, integers, and all that. So now we've gone into machine learning. So is there any particular roadmap in this machine learning? Is there a particular order? Is there a particular model we should learn? Like should we do it like in an orderly manner, or we should just pick anyone, just pick regression and learn, just pick predictive modeling and learn, just pick forest, the one you mentioned and learn, just pick the tree model, or is there a particular order you can recommend for us?
That's a really good question. Yeah, there's an order. There's actually an order to it. Each of the models actually builds on the previous models, and they sometimes looks at correcting the mistakes or the flaws of the other model. Usually, the steps to follow is you learn your linear models first. I would say this is a good place to go to. Yeah, this is a good place to look at stuff. This is not the order anyway, but this is a good place to be. Look at linear models. Just the types of linear models. Have a full grasp as much as you can of linear models. Go to tree-based models. All right. When you're done with tree-based models, you will definitely come across clustering. When you're done with clustering, the next step is usually multi-layer deep learning models, neural networks. All right. So from there, you're free to run wild. But the steps is start with linear models, go to tree-based models, do clustering. Now, something is interesting, right? That before an organization will want you to use large language models or those advanced models, we usually start with basic models. They want to see the base form of what that data set will produce. So that's why it's important that we know these models. Like start from the basic linear models and the tree models. In fact, in one of my projects, I did something that I had to combine both linear and tree models into one model, into building one big robust model. So start with linear models, tree models, clustering. That would be how I would encourage you to start. But from everywhere at all, before you do anything, what you learned in the morning is key. Knowing the model is good, but knowing how to process your data is even better. So
Silent very well.
have
Dama kan ce
spend
kinki
time
ya. Amalu mai fiye wata kan wanya.
spend time
Hey,
spend time processing your data. And yeah, but you have the progression is linear tree, clustering, neural networks. Yeah.
Okay, thank you, sir.
Okay, any more question? Any comments? Any suggestion? Any feedback before we close the curtain shortly?
Hello?
Yeah, Emmanuel.
Yeah, this is just to appreciate the New Life Research Foundation and all the instructors for taking out their time to give us the basics about Python and machine learning. I must say that this has kind of ignited a spark in some of us who Itato hasn't taken this area that seriously, despite the fact that it has a lot of applications in my discipline. My discipline is petroleum engineering, and I believe that the knowledge I have gotten will propel me towards becoming very good in this area, and the knowledge will help me to solve problems in my discipline. So I appreciate New Life Research Foundation immensely, and I'm very grateful to the speakers. I praise that God will continue to protect you all and continue to reward you through Christ our Lord. Amen.
Amen. Thank you so much. And like you said, this was actually to create is get us to know that we should venture in, and there are areas that we can use to apply even in our existing field that can make us stand out. Because some persons, they just hear, and for people when they hear AI, the only thing they're thinking about is chat GPT or something. But this was to create more awareness and to just create and just start something new that would propel you to want more and give you direction on areas we want to build on. So there's no way this was going to cover anything. This was just to stimulate something in you. And for some persons, it's a reminder. Maybe you've been praying and trusting God, where do I go? Where do I start? This is like a starting point, just to let you know. So if you have any other yes, Roland has dropped his means of communication. You can reach out to him, but please, when you are reaching out to them, be polite as possible. It's very official, and try to not go and disturb them, and try to be kind and polite when reaching out to them. We shouldn't be saying it, but people have overstepped their boundaries while communicating with people over time. So please, let's be as polite and civil. We know we are Christians. We are good people. We are good citizens. So please, not let's not take this opportunity for granted. So I don't know. I dropped the attendance link earlier, and I've dropped it I think how many times already. Please don't forget to fill the attendance. If you have a question, please tell us, because the attendance is from the attendance that your certificates will be sent to you. And we're going to be sending further information to us. We would, in case you're in need of resources and links that you would want us to share with you, please feel free to ask us. We would share it to you. We'll send them to you. And please, is there any other question? Let me call up someone to say a final word as we close.
Yeah,
When there's no question, okay,
just
continue.
an advice, right? Just an advice, right? This is in no way exhaustive. No, like this is
Yeah.
like one class. You will sit, yeah, like one class you will sit in a machine learning class. So this is in no way exhaustive. But the good thing is this, that we have resources. You learn every day. If you want to, you learn. For me, learning never stops. It's not in the classroom alone I learn. So outside, the field is such that what you know tomorrow may change. What you know yesterday may change tomorrow. So you have to keep learning, and it starts from today. So just pick up yourself and say, okay, God, help me to just learn. And the good thing is we also have a community. Yeah, I'm a bit private. I know that's a drawback. I know. Yeah, I'm a bit private, but there's no way you'll reach out to someone to New Life that they would not reach out to someone that can walk you through something. So guys, you're in the right place. Make use of the resources you have. either scholarship or whatsoever you want to do. Make use of it. And this is like when Peter has fished for so long and he couldn't catch anything, and Jesus asked him to trace nets at a particular place. So by God's grace, we have asked you to throw your net. We have shown you where to throw your net, but now we are asking you to expand on that place we've shown you and go deeper. And well, by God's grace, you'll be good and better than whatsoever you have imagined. All right, guys, thank you so much. That's it from me.
Thank you very much. Like you said, this is I don't want one thing that I want to say quickly before I forget. We should not don't see this as one of those conferences or meetings you attend that you go and dump the information. Make sure that you build on these things that have been taught, that you go and start looking at YouTube videos. Forget that maybe everything seems confusing. I tried to learn something in the last 6 months. I thought the first I've been saying it was like rocket science. I started learning it step by step with instructors. I'm amazed at how much I've been able to grow and excel in it, and I can teach people some of those skills already because of. But this was something that started when I looked at it like I don't think I'm ever going to be good in this thing or know this thing, but by constantly looking at materials, watching YouTube videos, reading blogs, and checking out as much resources as I can, taking extra courses aside the ones my instructors were using, has been able to make me build more, and I'm still getting to learn. So please, make sure that you don't just go and throw this knowledge and say, okay, they've started, I just want to get the certificate and get out, and that's all. Please go and read, go and watch videos, go and ask questions, look for mentors to follow and people you can easily involve in projects just for. I'm currently doing some projects with friends. We are not going to use it for anything. We're just using it to practice the skills we've been able to learn in the last how many months. And we're going to put so much effort in that project. But it's for fun, just to learn. You can do so like that too. So Mr. Lupe, please can you quickly give us a closing remark before I hand up?
All right, so thank you very much for that. We are coming to an end gradually. We started yesterday and we were doing roadmap to data science and AI. Today we had different sessions where you had opportunity of starting to learn about that roadmap. If you see how we planned this day 2 event, it was planned based on the roadmap to data science and AI, just as we did yesterday. We started with basic statistics. We went down to object-oriented programming, and then we went down to data structures in Python, and then we had the intro to machine learning and artificial intelligence. This is just a starting point. This is our inaugural program. We look forward that this will not cease from today. You are going to see many of these programs. They are going to come up. Keep following us. Join us on our platforms. We have different social media platforms. You can join us. We have a website. And most importantly, we also have groups. We have groups on our website, which they are going to go live latest by July 15th. Join us in our training group. We have a training group where all these resources will be shared there. You can ask questions, coding problems, and all that. You wouldn't want to be away from this community. You would like to connect with more people. You never know how that connection is going to change your career. So we invite you to join our platforms, sign up on our website, join as many groups as possible. We have so many groups and forums. We're inviting you to join them and see how they will help your life as we take this step to data science and AI. And we're also looking forward that some of you here will come back as TAs and as our instructors. We are looking forward for that. Lastly, before we go, I would like to ask you to show your face. We want to take some screenshots. So if you don't want to show your face, this is the time to show your face. We are right here and we want to take some screenshots. We'll be doing it.
Yes, please just take a selfie.
Thank you.
Screenshot.
If you want your face to show on our groups and to go to DC.
No, we want everybody's face to show, whether you want it or not. We want it.
We're already taking pictures.
See fine faces so.
All hiding. All right, so we're moving to the next. So we have so many, so we have to be taking from one slide to another. So still show your face. We have 3 different pages. It seems some people are appearing on all the pages, Tachia and the rest, Moses. Okay, Emmanuel. All right, let me go back to the first page. It seems more people are showing their faces. I made a mistake okay, I'm gonna take it again.
Okay.
All right.
Many people are not only putting in the cameras.
Yes, so, okay. Gloria, we are taking the picture. You're already showing. Thank you very much. Thank you, thank you, thank you. And just like Roland said earlier, you have to keep practicing. And we have all the resources on our platforms. If you visit our Facebook group, we share resources every week. If you check our featured post, you will see hundreds of slides for basic statistics, several slides for object-oriented programming, all this roadmap. You will find these resources on our Facebook page. Just go to our Facebook group, click on features. You will see all our featured posts. All the pinned posts, you will see them, and you'll be able to build from there. So, Sister Esther, you can take over from there.
Okay, thank you so much. And at this point, I really want to appreciate all our instructors and our TAs for wonderful job well done. This took a lot of process, a lot of time and effort, and we really need to appreciate them. This was voluntarily done. This was done they didn't charge us any amount of money. And so it's a lot to do this for free, with putting so much effort and time, not sleeping, staying awake, and sending all this. They had to be around for a period. They had to attend so many meetings. They had to attend some meetings and be available. This is a lot, and I want to really appreciate all of them. Deepan and Abraham, Emmanuel, Ocholi, Andrew, Joseph, John, Joseph again, Joseph Senum, Terkuma, Abi Roland, Saaondo, and everyone that has contributed, and even our entire team at our organization that has contributed to the success of this event. I really want to appreciate every one of us. We do not take for granted this level of sacrifice and effort that has been put into making this a success. We really wanted to say thank you and thank you and thank you. We would not be able to, words alone are not enough to appreciate you for this, and we look forward to working with you even more and doing more amazing things in the future. Thank you so much. And so at this point, whatever other information we have, we'll be communicating it to us via email and our platform. You can drop your question, your comments, your suggestion. So I know so this is where we are calling it, we are closing the curtain here. Thank you so much for joining us. I would let's quickly pray. Who would I call to round up the prayer for us? Who is here? Says to pray for us. I can see your face. So Yeah.
We are praying in the name of the Father, the Son, the Holy Spirit. Faithful Father, we
Amen.
thank you so much this wonderful opportunity given to us. Father, we thank you for the gift of life. We thank you for the sessions, these programs, oh God. I pray, oh God, for New Life Research Foundation, that Father, may you bring more connections and more wisdom. Empower them, oh God, with more techniques and more programs to bring and create and bear fruits in the lives of as many that come across them. Father, for we that have benefited from this program, may give us the grace to go forth and explore more to be fruitful. We ask all this through Christ our Lord. Amen.
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 Thank you so much. And this is bye from here until next time, next year, and whenever.